Let's look at number one. John is selling pizza to earn money to go on a band trip. Each pizza costs $10. He sold pizzas to five of his friends. The table below shows his sales. So we have friend, number of pizzas sold, and cost. And then the bottom row is total. It says which would be the recursive formula for the cost of pizza. So this is one of the things that we didn't spend time on, but we've seen this stuff before. But how it's written, we haven't seen before. But y'all saw it on the benchmark. So that's why we're going over this. I do want you to circle cost of the pizza. When you see the words recursive formula or sequence, what we're looking for is the pattern. And that's going to help us answer this question when we look for the pattern. Cost of pizza. So we're going to look for the pattern here. What is the pattern going from 1 to 2 to 3 to 4 to 5? What's happening? So adding 10, yeah. But not the last one because that's your total row. So I'm just going to mark that out because really we don't need that. We're just looking for the pattern for the cost. So what is happening? What is the pattern? Yep, add 10 to what? The previous to get your new one. So if you were to guess on this, look at your answer choices. What would you just guess? F. Why? Yeah, because it says plus 10. And that would be correct. But what this A with the subscript of x minus 1 is that means that's how they identify what the previous is. So it's saying the previous plus 10. Or they could do A n minus 1. So a subscript is kind of telling the position that the value is in. So if you're wanting to know what AX is, you take the previous and you add 10 to it. That's what it is. So you might have one problem like this on your test. The other kind of look that you'll see, so put a little box over here in the corner. This one was on your benchmark. It looks kind of like this, where it had a table. And it was a little bit different than just adding 10. Well, I add 20 here, then what would I add here? So what would it multiply by? 2. So is the pattern times 2 every time? Oh, why did I say 10? Sorry. 2 times 2 times 2. So it's something like that. And the way it'll be written is it'll be like AX equals 2 times AX minus 1. So you're looking for the pattern, and that would be the notation of how you'd write it. So, like, this is considered A1. This is considered A2. This is A3. So that's what it's representing. All right, let's go to the next one. So some of y'all may have had this problem on your mirror test. It says which of the following tables does not represent a functional relationship? It's been a while since we've seen this though. Yep. So to be a function, x's cannot repeat for a function. So if it's not a function, then x's do repeat. To be a function, x's cannot repeat. So you look at all the answer choices and see which one is not a function. The first one, we're looking at the x's. Do any of those repeat? What about 1, -1, 2, -2? What about this one? Yeah. So it repeats. So that means that that is not a function. But then j is a function. So just pay attention to the word not on that one. Number 3, which of the following is true if f of x equals x is transformed to h of x equals f of x minus 2? So what they're saying is we have this one. This is our original. And it's going to be transformed. So the different kinds of transformations are translate, reflection, or compress or stretch. Those are the kinds of transformations that we have. To get to this one, which is our new one. So it was transformed. So we got to see what is the difference. So this is f of x just equals x. This is h of x is f of x minus 2. So we have done this. We did it with Quadrat a couple weeks ago. So this is going to be when we look at if it's either inside, because see how it's f of x, but now this is f of x minus 2. So the change happened within the parentheses. So inside parentheses, like x plus or minus a. Inside the parentheses with the x is called the crazy x. Y'all remember that? Crazy x does the opposite of what you would think it would. And inside determines how it's translated left and right. So translate left or right. So it's going to do opposite of what we think. So if it's f of x minus 2, so it's opposite of -2. So you're going to go left or right. So whenever you think of -2, you think it's going to go left in the direction that's negative. But since it's with the x, it's a crazy x, so it goes the opposite. So this is going to cause it to go right by 2 units. I'm going to put that f out front, f of x plus or minus a. So it's with the x, so it does the opposite. But if it was outside the parentheses and it was f of x plus or minus a, that makes it go up and down, but it's not a crazy x because it's not with x. So translate up or down, because you could have a problem like this where it's outside the parentheses. So you would, if it was positive, it'd go up however many units. If it was minus a, it'd go down that many units. So you got to pay attention, is the change happening inside the parentheses like this one, or is it outside the parentheses where it does f of x plus or minus a? And then if there's a number in front of the f of x, that's some kind of stretch or compression. So this says steeper. This says shift left. It says shift down. This says shift right. So it's a shift right. Number 4. It has been a while. I think I saw this on page 50 of my journal. And we're on page 127 now. So it says if y bears directly as x, when y equals 6, x equals 15, solve for y when x equals 20. Do you remember these type of problems? What do we set up? A proportion, yep. So a proportion is two fractions that are set equal. Then you can do cross multiply and divide, or you can find the common factor. So we'd go like that, y over x, and we'd write this as a fraction. So y over x. So be real careful with how you put them, position them above or below. So this would be 6 over 15 equals, solve for y. So we don't know what y is when x is 20. We put a 20 here. 20 goes on the bottom because the x's are on bottom. You could find out what's being multiplied by 15 to get 20 and then do the same thing times 6. Or you can do cross multiply and divide, whatever way you remember how to solve proportions. 6 times 20 is what I normally do. I multiply the diagonal and then divide by the other number. Eight. So if they were to ask, you could put 8 or you could put y equals 8. These are easy problems, but we haven't seen them in so long. I wanted to make sure to go over it. All right, y'all read number 5 to yourself. So important information would be had a population of 27,500 and the function models population T years after bankruptcy if it decreased by 6% or by 4% each year. So what does 27,500 represent? Total that we start with, right? So let's write that start is 27,500 people. And it decreases by 4%. What do we need to do to 4% though? Decimal, so it's 0.04. Okay, let's look at our answer choices. Do you remember what kind of functions these are called? If it's a rapid increase or rapid decrease. Yeah, it's exponential. And this is a problem that they're going to put in to try to confuse you. Because we don't put the rate, we put how the rate changed. We always compare it to 1. So if it grows, if it's a growth, then we do 1 plus the rate. You always compare it back to 1. You never put the rate inside the parentheses. But if it's decay, you do 1 minus the rate. So this one says decrease, so we're going to take it away from 1. So we're going to do 1 minus 0.04 to get our growth or decay factor. Mm-hmm. Yep, you always put the start first, and then you do that growth or decay factor. If it's growth, it'd be 1 point something. If it's decay, it'd be 0 point something. So that is the correct answer. They switch these around, so that's not right. They put a number up here. They put both numbers here. That's not even anything. Yep, go ahead and glue this on, and we're going to do the next one.